We now turn to a somewhat higher timescale and concentrate on the operations and performance impact of the Interrad Dynamic Spectrum Allocation SON function. At an hourly timescale, the Dynamic Spectrum Allocation algorithm monitors the load levels of the co-located GSM and LTE cells in the greater Hanover area and, upon an observed need and opportunity, silences GSM spectrum to support the deployment of an additional LTE carrier, for instance, by reducing interference on key subcarriers of the secondary LTE carrier. The objective is to enhance the performance experience in the LTE network without degrading GSM performance. As for the policy-based SON management scenario, this scenario also covers 195 LTE macro sites, while the previously ignored co-located GSM macro sites are an essential part of the network environment for the current demonstration of the Dynamic Spectrum Allocation SON function. As before, in the considered baseline scenario, the SON function is switched off and fixed spectrum assignments are used for the GSM and LTE networks. We now click the DSA button on the network panel in order to zoom into an interesting area for this scenario of about 8 by 8 km in Hanover, featuring 36 co-located GSM/LTE sites. We raise the demonstration speed to 1000 times real time in order to run through the 24-hour baseline scenario fairly swiftly. On the network panel, we recognize the presence of the co-located GSM LTE cells by the split sector markers, of which, looking away from a given site, the left half represents the GSM cell, while the right half of the sector marker represents the LTE cell. Note that both halves are colored separately to show, in the current view, the average loads experienced in the different cells. The most heavily loaded LTE cell is noted to be this cell here, which is the prime candidate for extending the LTE spectrum. If we configure the sector markers to display the amount of spectrum available to each cell, then we see that these spectrum assignments are indeed static, since the Dynamic Spectrum Allocation SON function is still disabled. Note the traffic intensity map displayed in the background, which is varying over time, with traffic peaks occurring between 8 and 11 am and then again between 3 and 6 pm. The KPI panel shows the performance metrics that are most relevant for the Dynamic Spectrum Allocation scenario. More specifically, the top chart shows the aggregate load on the primary and the secondary LTE carrier in the noted most heavily loaded LTE cell, while the cell load of the co-located GSM cell is shown in the second chart. The last chart shows the maximum data throughput that can be processed by the considered LTE cell, as well as the actually processed data throughput in the cell. From the top chart, we observe that in this scenario, hence without DSA SON, the LTE load in the busiest cell reaches the 100% level for a significant amount of time, which likely causes severe performance problems in terms of poor user throughputs. The same underlying problem of congestion or overload is indicated in the bottom chart, where the cell throughput hits the current maximum value. Observe further from the middle chart that the co-located GSM cell is relatively lightly loaded, indicating the potential to turn off some GSM capacity in support of deploying a secondary LTE carrier. On the operator panel, we now enable the Dynamic Spectrum Allocation SON function, deploy this change and then shift to the next day via the time control panel in order to activate the SON function. Concentrating on the most heavily loaded LTE cell on the network panel, observe that at 9 am an overload is detected by the SON function and a secondary LTE carrier is deployed at the cell, which is supported by disabling a key carrier in the co-located GSM cell. Then, 4 hours later, at 1 pm, the DSA SON function observes that load on both LTE carriers have fallen below a predefined threshold. 1 hour later this occurs again, and then the DSA SON function decides to undo the temporary spectrum assignment. More specifically, the secondary LTE carrier is disabled and the barred GSM spectrum is reactivated. The same spectrum reassignments are done between 4 and 8 pm. Scrolling through the log messages window on the operator panel, we recognize these events that are generated by the SON function. For example, at 9 am indeed, an event is logged stating that the SON function detects an overload at LTE cell L1800A3131C1 upon which the action taken is to deploy a secondary carrier in the LTE cell and disable the carefully selected carrier with index 56 in collocated GSM cell G1800A0131C1 for interference reduction purposes. And indeed, at 2 p.m., an event is logged stating that the secondary LTE carrier temporarily deployed in the LTE cell is once again disabled, while furthermore the barred GSM carrier is reactivated. When viewing the effects of dynamic spectrum allocation on the KPI panel, we recognize the jumps in the load curves on the top two charts at the moments of spectrum assignments and reassignments, in the sense that at times when a secondary LTE carrier is deployed, the aggregate LTE load decreases as a consequence of the suddenly raised cell capacity. In particular, it falls well below 100%, indicating that sufficient capacity is now available to handle the LTE traffic. At the same time, the GSM cell load increases due to the sudden reduction of the number of available traffic channels. Observe, however, that the GSM cell load is still clearly below 100%, reflecting the fact that the reduced number of available carriers indeed suffices to handle the GSM traffic demand. The opposite behavior is seen whenever the temporarily added spectrum is taken away again from the LTE cell. In the bottom chart, the increase and decrease of the maximum data traffic handling capacity of the LTE cell are clearly visible at the times of spectrum assignments and reassignments, visualizing the potential of the dynamic spectrum allocation SON function. It is noted that without dynamic spectrum allocation, it would be impossible in the shown scenario to handle the traffic demand for the most congested LTE cell of the entire day.